here's the next part of the puzzle. This is a DC-DC boost converter only, not a buck converter, and it has constant current and constant voltage. On the input side, I've got a temporary 2.1mm jack. I don't really like these things here because they're asking for a short circuit, but just to rig something up and test something, it should be fine. So I'll just go ahead and install this temporary 2.1mm plug onto the other side. This is the output side. So this is the side I would connect to the charger and hopefully get, I'll probably put 20 volts in. I don't know if I'll put the full voltage in or not. And this will allow me to just really quick try this out, see if it works. I don't yet know how I'm going to test the constant current part. I believe this particular board I've already experimented with earlier, and I think I have the current turn as low as it'll go, so it may actually not do anything. So I need to put a voltmeter on the output so I can see what it's actually getting. I think I would just use a multimeter for now to see what the actual output voltage is on this thing. So I'm going to bring this over to the other workbench and connect it and see what happens. Alright, I'm going to power this thing up. I've checked the polarity to make sure it's correct. It does not have an LED on it, so you can't see if it's on or not. I'm going to connect to the output. I'm going to connect a splitter, which is right here. And that will give me the ability to make multiple connections. Before I connect the power tool charger, I've got to verify what the output voltage is. I will use my breakout cable and another plug right here to connect my multimeter. Put my multimeter on 200 volts and connect the multimeter to the output. And we're getting 19 volts. Okay. Could go ahead and start the experiment with 19 volts because it'll run on 17 point something. It'll run on 19.3. I guess that's what I'll do. I don't really need to adjust anything. So the only other question will be the current. And the current is actually handled by this potentiometer right here. Now I know it's not super clear because the camera isn't zoomed in, but there's two pots. You can see them right here. The voltage is already adjusted. This is the current. I don't know what the current is currently turned up to. So I think I'm just going to plug it in and give it a shot and see what happens. Okay, the picture is getting kind of crowded, but here's one of the plugs on the breakout cable. I'm going to plug that straight into the charger. And you saw it light up. Okay, so it's still getting 19.3 volts on the input. Next, I need to put a battery in there and see what happens. So let's go ahead and do that. The warranty is certainly void now. And it fell to 18.7 volts. It's working. That's very good. It's actually functioning. I'm not worried about the low input. It's only doing 9 watts, and I know why that is. That's probably the constant current on my boost converters turned way down. So it appears to be working smoothly. It's hard to see the meter, but it's right here, and you can see it says 9 watts. I have moved the camera up so it's easier to see the meter. What I'm going to do is slightly turn up the current on the boost converter just a little bit and see what happens. I think I would like to see 1 or 1.5 amps going into the battery. That would be enough for me. In actuality, I can't see how much current is going into the battery, but I know it's going to be less because we're boosting. But if I hit about 1 amp on the meter, that's satisfying for me. I don't need to charge my battery faster than that. So I'm going to give the current pot a little bit of a tweak here and see what happens. It's really hard to get on these pots. They not very easy. I'd rather have a knob, a large knob here to turn. Alright, let's try turning it to the right. Nothing so far. I know I can get more than 9 watts out of this panel. Okay, turning it to the right reduces it. I'm going to try turning it up. So I'm turning it left. And it's creeping up a little bit. Just keep turning it. And actually it's starting to go up now. So the solar panel is at 17.6 volts now, and I'm loading it more and more. The battery charger acts a little bit strange. It seems to be stopping and restarting. Or maybe I just don't understand how it works. So I'm going to keep turning it up. And it's 0.89, 0.9. Pretty good. It's about an amp. See if I can hit an amp here. There we go, 1.06 amps. Now that's going in to the boost converter. The boost converter is going to waste some of it, but the rest is going to go into the battery. And the boost converter is holding 19 volts, which is good enough, but I might want to raise it to about 20. I have raised the boost converter's output to 20.5 volts. That way, technically the battery could never be fully charged. It would probably be 90%, which is okay by me. That's kind of what I wanted. Let's go ahead and give this another try. $18 watts. 18 watts is not making it to the battery. Some of it will be wasted by the circuitry, but I'm guessing the battery is getting about 1 amp. I don't have any amp meter connected right now to measure the current. You can see the boost converter is holding about 19 volts. It doesn't seem to be getting warm. This boost converter is actually pretty good. It's pretty heavy duty, and I like it so far. It was listed as a LED driver, but you could use it for all sorts of purposes if you're careful with it. While the battery's charging, I'm a little bit curious to know what is the actual voltage of the battery. So I'm going to measure the actual battery itself and see what its voltage currently is. I will need to be careful I don't short something out, so I have to pay attention here. This board has a conformal coating on it, and it makes it really hard to get a connection. You have to push pretty hard. And if you slip, you can short something out. Okay, the battery's currently at 19 volts versus 19.3 or 19.2 volts on the input, which is shown right here on this other meter. So there's a little bit of a drop through the circuit. Obviously, a solar panel by itself isn't going to do much of a charge on a battery like this, since 19 volts is nothing to write home about. This particular battery was almost dead, so 19 volts is certainly not fully charged. So you really need 20 volts, and to hold 20 volts at least to get any decent charge into a power tool battery that has a 5-cell lithium battery. Back over at the other workbench. So I like the way the charger performed. Obviously I would like to run it straight off of a solar panel, but I can't do that because the voltage is mismatched. So I have to have some kind of circuit to boost the voltage. Here's how I think the circuit can fit right inside the case. It can go right down here, almost as if it was meant to fit there. Now there is a concern of shorting on this connector right here, so I can't risk that, but physically and mechanically it does fit. So I just need to find a way to insulate the circuit board so it doesn't touch this connector right here. I'm going to proceed with this modification, but I'm going to do it in such a way that it doesn't take up too much time. I don't want to spend too much time on it. It could malfunction, it could break or burn out. It's not necessarily going to work. It appeared to work at first glance, but I have to be careful and test this a lot longer in order to be sure and to be satisfied. So what I'm going to do right now is just throw some electrical tape in, and I'm going to put the board in there on top of the electrical tape. I'm going to put more electrical tape on the board to make sure it doesn't short anything. The circuit board of this boost converter is actually a aluminum PCB. It's made out of aluminum, so I have to make sure that doesn't touch anything and short it out. And I think I can just put the circuit board right in here, put a lot of tape in there, and I should be able to start testing this. Yeah, it looks pretty good in there. And I may put some hot glue in there just to make sure it doesn't move around. There's how the board sits, and to show it fits, put the main circuit board back on. It goes right on there, and it's actually not making contact at all with the main circuit board. The boost converter circuit board is not touching the main circuit board. I would just need to make sure it doesn't move around. This is okay for an experiment. Should be fine. So I'm going to get some hot glue going. I'm going to first solder all the connections on here. This is the input right here. That'll need to come around here to where the jack is. That's where the jack's going to go. And the output would need to go right here where the jack was temporarily attached. So I'll go ahead and take care of that, and I'm going to give this charger another try and see if it works. Also, this boost converter ran completely cool to the touch. I could not tell it was warming up at all. This is a heavy-duty boost converter, so it's not working very hard at all. and I don't think there's any chance of any malfunction. As long as I don't exceed a 100 watt solar panel in the input, I really don't believe that this could ever malfunction or overheat, but I will test it thoroughly just to be safe. First I have to remove the 2.1mm jack that I temporarily attached. This jack will not fit where the original power plug was, so I need to drill it out so that this jack here, this 2.1mm jack, will fit in. I am putting the screws back in. I've closed the case back up because I need to drill out this hole here so I can put a 2.1mm jack in. This is just a temporary step. I think 3 of the screws in ought to be enough. Normally it's not a good idea to hold the item that is being drilled out, but I'll use low speed and be careful, and I don't think this box would injure me too much if it turned suddenly. It's not sharp. Looks like the case is coming apart a little bit. Okay, that will fit. I need to clean all these bits of plastic. And for that I'm going to use my little handheld USB shop vac. The 2.1mm jack will have to be pre-attached and pre-assembled because I can't tighten this nut on the back of it once I've closed the case. Hopefully I'll be able to just put the case on there with this tightened on like it is now. Hopefully that'll be good enough. And some hot glue would probably help as well. To prevent the board from short-circuiting, I've attached some electrical tape on the top because it is metal. And I believe I can just set it right down there like that. Some hot glue can help hold it down. And I'll just run all my wires and make all my connections. Probably should use a fuse, although I'm going to be using a 100 watt solar panel and I'll never use anything else. So I probably could get away without one. I think for testing I'm just going to wire it up for now. What I would like to add to the input is a poly fuse, but I don't have a poly fuse. I could always open it up later and attach one, so I'm not going to worry too much about it right now. Right now I want to test this a little bit more and see if it still works for me. After maybe 1 or 2 full battery charges I'll be convinced. I'll just go ahead and tin up these wires on the input and output of the boost converter. Now I will connect the wire called VN positive to the positive of the 2.1mm jack on the input. Now I'll connect the negative. I don't really know how long I'll be using this charger or whether it will be a real success, so I'm not going to spend a lot of time heat shrinking. I'm going to use a little bit of hot glue on the interior, and I'm going to connect the wires together and I'm going to run a longer test on it and see how it performs. This is the output of the boost converter, so this needs to go to the positive. And I'm just going to tack them together. There's the positive. Got to make sure and get the polarity correct. That's the negative. And the wires are a little too short, so I'm going to have to work something out here. There's all the connections made. I use electrical tape I'm not really wanting to waste heat shrink on this right now because I don't know what the final form will be. This is a prototype, and I probably will make changes to it, so I'm not going to waste heat shrink. Now what I need to do is probably a little bit of hot glue on the wires and just make sure nothing is shorting out, and make sure this board is in the right position and not shorting on anything, and then basically just run this for a couple batteries and see what happens to it. Now I'm going to use some solar powered hot glue. I'm going to use my Ryobi hot glue gun, my fake Ryobi battery that burned up, and I put a 2.1mm jack in it. You can see it right there. It doesn't weigh very much. I put it inside the hot glue gun, and then what I can do is plug my 2.1mm cord in and power this hot glue gun using direct solar power. And I did make a video about this, but I'm still using the tool and it works very well. Alright, let's plug it in. I don't know if this cable is going to be heavy duty enough. I may have to use a different cable. Plug the solar right in and turn the hot glue gun on. And 1.8 amps, 2 amps. It's trying. Hard to tell whether this will work. The cable's got a lot of voltage drop in it, so the tool requires a certain amount of power to run. Looks like it's dropping down to 15 volts, 50 watts. And the sun is shining on the solar panel. It's a 100 watt solar panel, so it's shining on it pretty good. 52 watts is not a problem, I guess. What I really need to do is get some better cables. This is a very thin cable. I think it's 22 gauge. It's ridiculously thin. So it's got a lot of voltage drop in it. Okay, so I'm going to let the hot glue gun heat up, and I'm just going to use a little bit of hot glue on my project here just to make sure the wires don't move around. I don't want any problems or short circuits or anything going wrong. Okay, the solar powered hot glue gun appears to have reached its operating temperature. It's using 24.5 watts, as you can see from the meter right there. And you can see it's still plugged in the solar with an incredibly thin cord. It's about 5 feet long. It's very, very thin. It does get a little warm, but it's good enough for now. I'm just going to put a small amount of hot glue on the circuit board and the 2.1mm jack because I don't want it moving around. And I figure anything I do to stabilize it, keep it from moving, is a good thing. I want a small amount of hot glue on the 2.1mm jack on the back because it has a nut on the back that tightens down, and I don't want that to accidentally come off. So I'm just going to take some hot glue and put it on there, and that will help prevent the nut from accidentally coming loose. And I need a little bit of hot glue on the other side of the circuit board. I'm referring to the boost converter circuit board. And on the wires that are connecting the boost converter. Just to make sure it doesn't want to move around too much. I'm not going to go crazy with the hot glue because I'll probably be opening this charger up again to make adjustments or modifications. And I don't want to risk putting so much hot glue in there that I have a hard time getting it open again. That would just be inconvenient. I think that'll do for now. It should be enough. Just for a test, now to see if the cover will fit. And I've already plugged power into it and the red light came on, so I think I got my connections right. Hopefully the other side of the cover will just fit on there. Gotta get the hot glue out. Got a little bit of hot glue in the edge here, and that'll keep it from closing properly. Alright. Let's put the lid on. Yeah, it went right on there. Yep. The jack moves a little bit, so I could tighten it up slightly. It's tricky because this is not how this type of jack is meant to be used. Actually, I think what I'll do is put a little bit of hot glue on there. Rather not do that, but just put it on right there on top of the nut. It's probably not a good idea, but if I had to, I could just pick the hot glue off. I don't think it'll be a problem here. I don't want that jack to come loose. Okay, there it is. Actually looks semi-professional, I gotta say that. Almost looks like it came from the factory that way, but we know it didn't. Now I need to put the screws in, and I can give this a test. There is the finished product. I guess we'll see if it works. This is the solar panel meter that I showed earlier, so it's the same exact setup. I'm using the same exact cord that I used for the hot glue gun and the earlier test. So I'm just going to plug that right in the back. And it has come on. It's a little bit hard to see, but it has come on. See if I can move it where it's easier to see the light. Actually, the light is pretty dim because there's an LED way in the back, and you have to line it up just right to see it. But it is coming on. Now I'm going to go ahead and put a battery in, the same battery I was testing with earlier, and see what happens. And it appears to be charging. You can see the green light is blinking right there. 18 watts. It is charging the battery, and at 20 volts, which is the output, I put it at about 20 volts. It should be enough to get an 80 or 90% charge. And actually, I don't want my batteries to be fully charged anyway, because they sit around a lot. I prefer to charge them to about 80% and not charge them all the way up. That way they'll last longer, they'll get more cycles, and it's just easier on the battery in general. There's the charger. You can see it better now because it's in a shadow. The green light is quite obvious. It's just charging away, 18 watts. Of course, I could turn it up higher. I think for a test it's better to be safe and stay around 1 amp. That's enough for me. I can always open this up later and change the trim pots to put out more voltage and more current anytime I want to. Since this is a test and a prototype, I don't want to push the limits, and I don't want to have any meltdowns or anything go wrong. In the long term, I'll probably get quite a lot of use out of this charger. I suspect that it will sit there blinking green indefinitely because the battery could never fully charge. That's not a problem for me. I don't mind a partially charged battery. If I want a full charge, I can always put the battery on another charger and get a full charge. I have a lot of other videos planned for similar topics and similar ideas. I just haven't had the opportunity to get around to them yet, but I do plan to do them. I hope you enjoyed this video about modifying a Ryobi power tool charger to run off of a solar panel. Thanks for watching, and I'll see you later.